Children, in the chapter Playing with Numbers, we are going to do certain divisibility tests to check without actual division whether a number is divisible by the given number or not. It is helpful when numbers are large. Let us have a look at the divisibility rules of the following numbers. Now, if the last digit of the number is 0, 2, 4, 6 or 8, then the number is divisible by 2. Now, for example, 30, 152, 96, 108, etc. The numbers are ending in 0, 2, 6, 8. So these are divisible by 2. Now if the sum of the digits of the number is divisible by 3, then the number is divisible by 3. Now for example, we have number 645. Now let's add all the digits. So 6 plus 4, 10, 10 plus 5, 15. Now 15 is exactly divisible by 3. So 645 is divisible by 3. Now if the last two digits of the number are either 0 or divisible by 4, then the number is divisible by 4. Now for example, we have a number 12,284. Now the last two digit here makes the number 84. Now 84 is exactly divisible by 4. So the number 12,284 is exactly divisible by 4. Children, I hope you know the divisibility test of 5. So if the last digit of the number is either 0 or 5, then the number is divisible by 5. For example, 105, 1080, etc. Now, if the number is divisible by both 2 and 3, then the number is divisible by 6. Now for example, here we have number 2484. Now here you can see the number is ending in 4, so it is divisible by 2. And if we add the digits, so we have 2 plus 4, 6, 6 plus 8, 14 and 14 plus 4, 18, which is exactly divisible by 3. So 2484 is divisible by both 2 and 3. So it is also divisible by 6. Now if the difference between twice the ones digit and the other digit is either 0 or is divisible by 7, then the number is divisible by 7. Now it will become clear from the following example. Suppose we have a number 343. Now the digit at one's place is 3, so twice of 3 is 6. So 2 into 3 is 6. And the other number is 34. So the difference 34 minus 6, which is equal to 28. Now 28 is exactly divisible by 7. So the number 343 is also exactly divisible by 7. Now if the last three digits of a number are either 0 or divisible by 8, then the number is divisible by 8. Now for example, we have number 29,152. Now the last three digits are 152 and it is exactly divisible by 8. So the number 29,152 is divisible by 8. Now, if the sum of the digits of the number is divisible by 9, then that number is also divisible by 9. For example, we have a number 81,324. Now let's add all the digits. So 8 plus 1 is 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 4, 18. Now 18 is exactly divisible by 9. So the number 81,324 is divisible by 9. And I hope everybody remembers that if the last digit is 0, then the number is divisible by 10. So here we can take numbers ending in 0. So we have 2000 or 510 or 390, etc. Now if the difference of the sum of the digits at odd places and even places is either 0 or divisible by 11, then the number is divisible by 11. This will become clear from the following example. Suppose the number is 90,728. Now first place is odd, second is even, then we have odd, even, then odd. Now let's add the digits at odd places. So we have 9 plus 7 plus 8, which is equal to 24. Now the digits at even places is 0 plus 2, which is equal to 2. Now the difference of these two is 24 minus 2, which is equal to 22, and 22 is exactly divisible by 11. So the number 90,728 is divisible by 11. I hope you have understood all these divisibility rules, and while finding out the highest common factor, please use these divisibility rules. Now let's learn how to find out highest common factor or HCF of two or more numbers by prime factorization method. Now the rule is, first find the prime factorization of the given numbers and then multiply the common factors to get the HCF. Now it will become clear from the following questions of exercise 5.4. Now question is, find HCF by prime factorization. So here you can use the divisibility rules, and remember you have to divide the given numbers by prime numbers only. So 170 is divisible by 2, and children always start with the smallest prime number which divides the given number. So here I have 285, then 5 17s are 85, then 17 ones are. Now here 238 will get divided by 2. So 2 119 is 238, and then 7 17s are 119, then 17 ones are 17. Now let's write each of these numbers as a product of its prime. So 170 is equal to 2 into 5 into 17, and 238 is equal to 2 into 7 into 17. Now let's find out the common factors. So here you can see 2 is in both the numbers, 17 is in both the numbers. So HCF is equal to product of common factors. So here 2 and 17 are common. So 2 into 17 is equal to 34. So HCF of 170 and 238 is 34. Now question number 7. In this question we are given 3 numbers now. So let's find out the prime factorization of each of these 3 numbers. Now 396 is divisible by 2. So 198 we get here, then 299, then 333, then 311, and then 11 ones are. Now 720 will get divided by 2. So 2 360, then 2 180, then we have 290, 245, then 315, 3 5s are, then 5 ones are 5. Now 1080 is also divisible by 2. So 2 540, then again with 2 we get 270, then again with 2 135. Now it will get divided by 3. So we get here 45, then again with 3 15, again with 3 5, then 5 ones are. Now let's write each of these numbers as a product of its prime. So 396 is equal to 2 into 2 into 3 into 3 into 11. I am writing from here. So 720, 2 into 2 into 2 into 2 into 3 into 3 into 5. 1080 is equal to 2 into 2 into 2 into 3 into 3 into 3 into 5. Now let's find out the common factors. So here you can see 2 is common one time. Then again 2 is common. So 2 is common 2 times. So here 3 is common one time in all the numbers. And again you can see 3 is common 2 times here. So HCF is equal to product of all these common factors. So 2 into 2 into 3 into 3, which is equal to 2 2s are 4, 4 3s are 12, 3s are 36. So we get 36. Now let's do one more question. So again we have three numbers, 144, 252 and 630. Now it is 144 is divided by 2. So here we get 72. So 236, then 218, then 3. You can divide with 3 or you can divide it with 2 also. So 2 9s are, 3 3s are, 3 1s are. Now 252, it will get divided by 2. So we have here 126. Then it will get divided by 2, 63. Then 3 21, then 3 7, and then 7 1s are. Now 630 will get divided by 2. So here we get 315. Now it will get divided by 3 and we get 105 here. Again it will get divided by 3 and we get 35. Then 5 7s are, then 7 1s are. Now let's write each number as a product of its primes. So 144 is equal to 2 into 2 into 2 into 2 into 3 into 3. 252 is equal to 2 into 2 into 3 into 3 into 7. 630 is equal to 2 into 3 into 3 into 5 into 7. Now let's find the common factors. So here you can see 2 is common. It is in all the three numbers. Then we have 3 common one time. And again you can see 3 is common 2 times here. So HCF is equal to 2 into 3 into 3, because 3 is common 2 times. So we have to multiply 2 times. So here we get 18. Children, I hope you have understood all these questions. Now for homework, you have to do question number 2, 4, 6 and 9 of exercise 5.4, and you have to learn prime numbers from 1 to 100. Thank you, children.